Another useful skill in this chapter will be write this sum into one single summation notation. And also the backwards, the reverse of that is write this single sum into two terms. One is the sum and the other one is the final term. Now, how do we begin with? So I hope that let's take a look at a simple scenario. Suppose I have this guy and a n plus 1, a k. So if I want you to expand this guy, so you will have the first one is a1, the second one is a2, and then of course an plus am plus k. When you see the am plus k, you know you should stop because that's your upper limit, right? Now, do you see that these first n terms can be written as a single summation notation? So sum of I k from 1 to n ak. And this very last one is just a m plus 1. So you can certainly combine these two into one single summation notation. Or you can write a single summation notation by separating off the very last term and write all the previous terms into one single summation notation. So that's the skill that we want to exercise in this particular problem. So now let's do the first one. Write this as a single sum. Now, sometimes it will be helpful if you are able to expand this summation first because it might be easier for you to see. So let's write this summation into the expanded form first. So it says I starts with 1, so 1 squared, that's my first term. Okay, plus increase the index by 1, so it becomes 2 squared, and increase that by 1, 3 squared. And what do you end? When do you end? When the I is equal to k, that should be your last term in this summation notation. So k squared will be your last one. And then now let's continue to copy this down, plus the k plus 1 square, right? Okay, now I hope that you do see that this guy can be actually written into one single sum. This is going to be, you begin with your I from 1. And then the very last one that you stop is when I is k plus 1, right? When this is k plus 1, then you stop. So therefore, k plus 1 is my upper limit. And still, each time you just square the index. So it's going to be your I squared. See, I combine this into this summation and write that using a single summation notation. Now let's do the backwards. Let's separate off the final term here. Again, sometimes if you're not that proficient at the moment, write that into expanded form will help. So let's write this. When I is 1, this is 1 over 1 plus 1, plus when I is 2, which is 2 over 2 plus 1. When I is 3, which is 3 over 3 plus 1, and so on and so forth. Of course, when each time it increases by 1, right? So, this is ki equals 1, this is I equals 2, this is I equals 3. And when I is n, it's not there yet. So when I is n, you get n over n plus 1. And then you have to increase this by 1. So I will be n plus 1 for the next term. Then you should stop because that's what the upper limit is. So therefore you have n plus 1 over n plus 1 plus 1, which is n plus 2, right? So now all these I can write one single summation notation, which is summation I from 1 to n, because n is the last one I want to include. Okay, so therefore that becomes my upper limit. This will be I over I plus 1 plus, and the very last one here is m plus 1 over the m plus 2 if you simplify the bottom. So m plus 1 over m plus 2. All right, so we successfully separate off the final term from this summation notation, and then we write that into a summation notation plus the final term. Again, this the skill of doing that will be very helpful in a later section of this chapter. I hope that you are able to do it. Now, in this video, I also want to introduce a telescoping sum, which is, let's take a look at this, okay? Let's expand it. So let's expand it. When k is 1, okay? When k is 1, let's take a look at 1 minus 1 plus 1, which is 1/2, right? Minus, here, when k is 1, 1 plus 1 over 1 plus 2, which is 2/3. So that's the first, when k is 1, that's what I get. Because this is summation notation, so I'm going to add. Now let's write down let's see what we have when k is 2. So it will be 2 over 3 here minus, so when k is 2, so 3 over 4 here, right? 3 over 4 plus, so when k is 3, and you can quickly write down the difference, so 3 over 4 plus 5, actually minus 4 over 5, and so on and so forth, okay? And so on and so forth. Now, when k is plus, when k is n, what will happen? This will n over n minus n over n plus 1 minus n plus 1 over n plus 2. Now, of course, in between each group, that's addition. We can actually drop the parentheses without any trouble. So therefore, you have 1/2 minus 2/3 plus 2/3 minus 3/4 plus 3/4 minus 4/5 plus, and so on and so forth, plus n over n plus 1 minus n plus 1 over n plus 2. Now, do you see that this and this can cancel? They cancel to 0. And in other words, the second term of my first group cancel out the first term of my second group, right? Similarly, the second term of my second group cancel out the first term of my third group. So these two will cancel. Based on this pattern, you will expect this guy will cancel out the first term of the next group. Similarly, for the very last group, the first term of this guy should cancel out the second term from the previous group. They should cancel out to 0. They should cancel out to 0. Okay, they should cancel out to 0. And all the middle terms, they collapse to 0. They collapse to 0. So that's why we call this as telescoping sum, because the pirates use those telescope. They can collapse after they use, right? So that's why it is called telescoping sum. So this is equal to, at the end, 1/2 minus m plus 1 over m plus 2. So this guy can simplify to that.